something that's going to stir with people's minds a lot. So, since we are a American professor came to Brazil and said, "Is it true that you have a energy source that's produced by man that causes a revolution and everybody wants?" And little Peter said, "Yes, we have a sugar cane." That it comes from a very interesting nature. We are a tropical country, so we have water, we have earth, we are a continental country, and we have sunlight. And because of photosynthesis, we have three products everybody wants. Sugar as food, ethanol to reduce the intensity of CO2 emissions, and bioelectricity, which reduces CO2 in the energy matrix. And these two main products didn't used to be the core products of sugarcane. But they represent 2/3 of a ton of sugarcane. So do you have the product? Yes, we do. And is it true that you're going to occupy the whole country planting this product? The answer given to this professor was no. And for that, Pedrinho used the John Deere map that shows that we can have 33 countries of Europe within Brazil, and there is still room for left for Amazon. Did people forget about that in your geography lesson? Many people think we are occupying the whole country planting sugarcane, but see the size of our country, a continental country. So yes, where is this sugarcane being planted? Well, very far from Amazon. It's 2,500 kilometers distant. It's too much logistics problems to plant there. And only in the areas we produce more fuel than the gasoline used. So we have a lot of room to grow. Yes, we do. And what is the forecast growth? We're going towards 1 billion tons of sugarcane. Slower or faster depending on the market conditions. But since we reach that level, the production will be about 65 billion liters of ethanol and 45 billion tons of sugar. What about bioelectricity potential? Well, it's a wonderful potential in terms of energy generation. Of course, this is a great main challenge for the industry, for equipment, but the biomass is here. So it's the equation I showed in the beginning of a positive environmental balance. But why don't you use that? Because you want to use all the land in the country. That's not true. Look at this FIO graph. Brazil, people are worried about India. They don't have any more land to expand on. Brazil has a lot of land still in terms of available land. So, having said that, we can continue with the idea of production. But there's something that's not good in Brazil. Our energy matrix or grid is growing a lot in terms of fuel oil. See, 530% of decrease in share of diesel oil. Why don't we grow more? 100%, 170% growth of bioelectricity. Is this our call? Why don't we use more of our biomass that's available? So here we see another picture that Jean has mentioned somehow. This is a snapshot of all the auctions of energy that have been carried out since 2005. It's a very significant amount of energy traded. So it's about time for us to plan our energy grid and not only obtain it from the results of the auctions. And in order for that to happen, we have to advance. We have worked on this chart here, and I mean to show you that since 2004, this model has allowed us to improve the generation produced. Today we have 360 mills characterized as bioelectricity or cogeneration. In beginning of this year, we're going to connect 840 more megawatts of energy that have been traded already. And next year even more. So there's a lot of potential ahead of us. All this information is available. We have a website that contains all this data. And where is this going to happen? This map shows the operations of bioelectricity and cogeneration. 85% of all sugarcane industry is located in these areas. The blue area, the older mills that need a retrofit process. And this process demands a lower amount of money because there's the connection network is out there, the industry, the equipment is out there. We just did a technological upgrade. The areas in red are greenfield areas. So it's from the combination of expansion, greenfield, and retrofit that we're going to expand.
These 20 states here in this map are responsible for this production. The state of São Paulo is at the level of 60 to 65%. What is happening in these states? Let's take a snapshot of São Paulo. There is a ruling from the entrepreneur in the public department to use fire. In this map, the green areas are mechanized harvesting, the red ones are manual. In this harvest, we have more than 50% of the sugarcane harvested mechanically. We are doing an operation that every owner likes. We'll supply the burning of the sugarcane and make it light. This gives sustainability because we are including an important environmental gain, and we are helping public health. This will happen in 2014, and we'll have a reduction in all the areas that are mechanized. And what we are going to do with this biomass, we are going to produce energy. The picture you have on the left shows the traditional process, heat and burning. The reason is sustainability, production of bioelectricity, and 70% of the straw goes to energy, and 30% will be left in the fields to organic recomposition. Below, the older boilers are 21 bar boilers. On the right side, a 92 bar boiler consuming 4.7 steam to produce the same kilowatt hour with the same biomass. That's our goal. It's a sustainable technology and increasing efficiency of the process, producing a positive environmental balance. We have here a forecast of what is this potential, both for Brazil and São Paulo. Imagining a theoretical forecast which is using known factors and market potential. That is the one we might reach. So the figure is really high. In terms of Brazil, it might reach 20,000 megawatts. This biomass exists, is available, and we either use it in an efficient way or we are going to do how the old farmers. You burn this biomass because we'll have more next year. The gas we have enough. We cannot think this way. We must think in terms of sustainability. So we have an important issue to complement the system. In the graph we have here, we show the importance, how to mix both periods, the dry and the wet. We are going to produce energy in the dry season. In the rainy season from January to April, we have a higher hydroelectric production, and sugarcane needs the rain to grow. In the winter, it needs the cycle of the climate to create sucrose. That's when it is harvested, and we offer this energy to the system. It is of vital importance. 1,000 megawatts in the southeast is like adding 4 percentage point of waters in the reservoir. This is how we understand complement. The other important is connections. We have a ruling today called shared connection platforms, the ICGs. We are applying this for greenfield areas, but can be expanded to all the areas. In terms of carbon, I have this data from February from the Technology and Science Ministry showing Brazilian position. The number of registered projects, Brazil has 14% of all projects. From these, we have carbon credits from registered projects where we stand at 14% level. We are losing for India and to China. But when we analyze in terms of installed capacity, what happens in Brazil, we see that sugarcane bagasse, which is the projects for generation of bioelectricity, represents 32% of the installed capacity of these projects that were approved for carbon credits, of which the distribution of states, São Paulo represents 22%. So we have experience in doing these projects of reducing emissions. And why don't we make more? So we have another important issue. Taking the participation of Brazil, what is renewable energy as a whole? It's 48%. From this, the first item, which represents 163 projects, we are talking about the projects that reuse the biomass, not only from sugarcane, but other biomasses are being used as well. The characteristics for the bioelectrical system, what do we add to the systems? We have these 10 commandments: inflexible generation, previsibility, small and medium-sized projects, proximity to the loading centers, environmental license, reduction of carbon dioxide emission, diversification of electric matrix, and localization close to the largest energy producer center. These factors represent complementarity, operational security, and energy security. The factors that ENS works to add value to this biodiversity to the system. Here it's estimate of values, believing that we'll reach 1 billion tons of sugar canes per harvest. How's the composition of the products we shown in the previous snapshots? It's sugarcane production, bioelectricity, and carbon dioxide taken from these conversions. Bioelectricity associated with carbon dioxide will represent in terms of billing 20%. But if we analyze in terms of results, it might reach 40%, which is completely different because its cost composition is completely different. So we have a point of view of opportunities, add value to the system, reduce emissions, reduce the emissions of carbon dioxide, and create economic factors that are indispensable, because these auction contracts, we sell energy derived from biomass, 15-year contracts at a fixed price corrected by the IPCA index. As we have all this, let's see how our sugarcane industry stands. Cane arrived in Brazil in 1500, and it was used by farmers to produce sugar. Undoubtedly, lots of people who worked there invented the other products, the liquor and sweet we have in Brazil called rapadura. After that, we reached at the Proálcool, and I would like to mention the participation of Minister Camilo Pena. The mills were started a new horizon in the energy production. Coming closer, 2005, we have